Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Sempai. Welcome back, everyone. Today we're jumping into a 12th grade topic, limits. Now, if you're new to my channel, I'll be putting time codes in for this video in the description box below. So use that to skip ahead to whatever part of the video you think is most interesting. As always, if you have any questions about what we see today or even your own homework, you can always put in the comment box below or visit my Facebook page at Tutor Me Sempai and tell me all about it there. At the end of this video, I'll be linking my 12th grade playlist in which I cover a lot more topics. So if you're interested in that, make sure you stay tuned. This video is only going to have 2 parts, so leave a like, smash the subscribe, and let's get started. Today we're going to be talking about limits. Now, limits are super important, ultra critical for the area of calculus. However, as important as they are, the concept of limits is actually quite simple. Let's say we have this function here, f of x. A limit is just going to be asking yourself one question. How does this function behave as x approaches a particular value along the x-axis? I can say that another way. What does this function approach as x approaches a number? That's all a limit is. So let's say we have this function here. And it's this. So we have our x-axis, we have our y-axis, and this is going to be some number a, and this is going to be the point a, b, because this is going to be b up here. So let's say we have this function f of x, and it looks like this. Well, the limit of f of x as x approaches a along the x-axis, how does this function behave? That's all it's asking. What is it approaching? So as x goes along the x-axis towards this a, this value a, your function gets closer and closer and closer to this point. And we know the value of a function is going to be its y coordinate, so the value of this is going to be b. Your function is approaching b as x approaches a. And that's going to be true from both sides. So let's say you're approaching this a from this side. So instead of going from this side, now we're going from this side. The same is going to be true on your function. You're approaching this point still, and you're still going to be approaching the same value b. So that limit is simply asking how your function behaves as your x approaches a particular value along the x-axis. And it doesn't even have to be constants. You can have all types of functions when you're trying to find limits. So let's say your function is a linear function. So let's say we're going to give it an actual number here. Let's say that's 2, and this is going to be, let's say, 5, right? Let's say you had something like this, and this is going to be your y-axis, this is going to be your x-axis, and your function kind of just continues. The limit of this function as x approaches 2 is going to be what? How does the function behave, or what does the function approach as x approaches 2? So as you're going along the x-axis this way, your function is going to be approaching what? This 5 here. Is going to approach that 5 here. And as you're going along the x-axis this way, your function is going to approach this 5 here. So the limit of this function is going to be 5. All you're doing is asking yourself a simple question. How does the function behave as x approaches a particular number along the x-axis? And if that definition is too hard for you, what does your function approach as x approaches a number? Now that we've covered the concept of limits, let's get into some limit notation. Actually, before we jump into limit notation, there's one really crucial piece of information that we need to clarify about limits. Going back to the definition that we talked about, the limit of a function is just going to be how that function behaves, or what does that function approach as x approaches a value along the x-axis. It is absolutely critical that I emphasize that the limit is what the function approaches. It's not what the function equals. it's what the function approaches. A limit does not care about what the function actually equals at a particular point. We're just focused on the behavior of the function. What does the function approach? Now, that may be the same thing, but it doesn't have to be. We're simply asking, what does it approach? If you wanted to find the value at a particular point, just simply plug it in. If it exists, it's going to give you that. However, that's not what a limit is. So going back to our linear, let's say we have something like this. We're not so much interested in what f of 2 is. If this is going to be f of x, we don't care about f of 2. What we care about is what it approaches. What the function approaches. Now, the function does approach f of 2, but that doesn't have to be the case. And we'll get into that in another video, but I just want to emphasize a limit is what the function approaches. Don't believe that it's always going to be what the function equals at that value. Now let's jump into some limit notation. So the basic notation for your limits is going to be as follows. So you have lim, you're going to write out lim, and let's say we had the function f of x. You're going to put that right next to lim, and you're going to take your independent variable, whatever this is here, and you're going to put it right here under your lim. Then you're going to have an arrow like this, and you're going to have the constant or whatever x is going to be approaching. In this case, let's say a. So this is going to read, what is the limit of your function f of x as x approaches a? And this is going to equal some value k, some constant value. So the limit, remember, we're approaching, a function is going to be approaching a particular value, and that value is going to be denoted by k. It's a constant. And that's, of course, if it exists. So this is the basic notation for your limits. But there's many different types of limits that we can find. They're all going to look pretty much like this with a little variation. Much of the variation is going to be centered around this. So let's list them all, starting with our basic one. So our basic one that we just talked about, the limit as x approaches some number a, f of x here. Remember, this is your independent variable, so you don't have to have an x here. You can have a few other things. Let's say you have an p of y or an L of m. It doesn't really matter what kind of notation you're using for your actual function. Your limit is not going to break down. Just take whatever your independent variable is, and I'll give you some examples as we write out more limits here. But this is going to be our basic limit. X approaching some constant a that's along the x-axis, and we're going to have the limit of this particular function. Now, it can be negative or positive, but let's write it out again so we can further emphasize that point. So let's say we have the limit of, let's say, another function. Let's say we have a g of m as m approaches negative a. So this is saying, let's say a was positive, right? You're going to have x approaches a positive number. Let's say a was still positive. It's going to say as m approaches a negative number. You can approach positive or negative numbers. It doesn't matter. Now, there will be times where you're not actually approaching a constant, but you're approaching an idea or a concept in mathematics. And that idea or concept is going to be infinity. Now, that's not actually a number, but we know what that means. So if we were to write that out, let's say we have our third limit, the limit of choosing another function, let's say h of n, as n approaches infinity. And just like you have a positive number and a negative number, you can approach positive and negative infinity. So that's going to look like this. So let's say we have the limit as of k of p as p goes to negative infinity. So you can go to a positive number, a negative number. The idea of infinity, you can go to positive infinity and negative infinity. And we have two other limits that we want to talk about. And those are going to be your left-hand limit and your right-hand limit. And I'm going to go back to f of x for both these limits because there's a point I want to make here. So let's say we have our left-hand limit. That's going to be looking like this. the limit of f of x as x approaches, let's say, a, the left-hand limit is going to have a negative sign to the top right of your value here. Your value a, you're going to have a negative on the top right. And your right-hand limit is going to be, you may have guessed it, very similar, except your plus goes on the top right. And this means that you're going to be approaching a from the left-hand side. Well, this means you're going to be approaching a from the right-hand side. These are going to be your left and your right-hand limits. When you're approaching a as a whole like this, you're approaching it from both sides. So it's technically both of these limits combined. And that's how you know you're going to have a true limit. You may not necessarily have a limit. And we'll talk about more of that when we get into limits and continuity. However, one sure way of knowing that you have a limit at a particular point is if your left-hand limit equals your right-hand limit. If that's true, then you have an overall limit at that value, and it's going to be whatever that value is. So these are going to be the different faces of your limit notation. I'll show you how to evaluate these limits at actual functions in another video. Today I just want to showcase what a limit was and introduce you to its notation. Well, I hope you were able to follow along with today's video, and I hope you now understand the concept of your limits. However, if you have any questions about what we saw today, or even on homework, you can always put in the comment box below, or visit my Facebook page at Tutor Me Sempai and tell me all about it there. If you hadn't done so already, remember to leave that like. It surely helps the channel by letting YouTube know that you found the video helpful. And if you found the video helpful, so can someone else. So leave a like, hit the notification bell, smash the subscribe button, and share the video with a friend. Well, that's all the time I have for today. I really hope it's helped with your homework. I'm looking forward to seeing you again next week. I'm Courtney. Here's your playlist, and this has been another session of Tutor Me Sempai.